Hi everyone, today we're going to be looking at 8.3 multiplying polynomials part 1, and that's going to start with, part 1 is going to be multiplying binomials. They're the easiest for us to start with. They're a good, beginning, beginning step into multiplying polynomials. And the other reason that we're going to spend all of our time on them today is because they're particularly special for our chapter. This particular chapter, we're going to encounter probably a lot of binomials. So we want to know how to multiply them together. Essentially, it's going to be distributive property, but we make it a little bit different. So I included right over here an example of my distributive property so you can see those 3 steps. I'm going to be recreating, in a sense, those 3 steps in my example 1. So if I wanted to multiply 2x plus 3 times x plus 5, I'm going to use the distributive property. But here's the thing that's weird. When I'm multiplying, this, like this and this, that looks like kind of weird, doesn't it? There's like an addition sign in there. Just like we can multiply a monomial and a polynomial, we're going to be able to do the same thing with multiplying 2 binomials. And the trick here is going to be, I'm going to box up this 2x plus 3, and then just like I did with the 5 here, the 5 gets multiplied by each of the terms of the binomial. I'm going to multiply this binomial by each of the terms of the binomial. So what's that going to look like? Well, I would have 2x plus 3 times x, which is a legal move. We can have x plus 5 times 5. That's the same distributive property like that. And then we'd have 2x plus 3 times 5. And that is our first step. So that's what we did here. We had those 2 multiplied together and those 2. So let's follow what's the next step. Well, the next step is to simplify or multiply our products together. So what I actually am going to do that is I'm going to use the distributive property again. And I know that this looks a little weird to have the numbers on the right side instead of the left side when you're distributing, but it is valid. And if it really, really bothers you, you can switch around the order, and it's not going to bother me. I might switch around the order in this video, unless, I don't know. I don't think it'll be too confusing, hopefully. So now I need to start simplifying this expression, as I was saying. So I'm going to use the distributive property, and I do 2x times x plus 3 times x plus 2x times 5 plus 3 times 5. So I've written out my distributive property again. I'm almost done simplifying it. So now it's going to be much easier for me to get to that most simplified step. So I have 2x squared plus 3x plus 2x times 5 is 10x plus 15. Okay, beautiful. This is really coming together. The last thing that I need to do is combine like terms, and you're going to be seeing a lot of combining like terms in these problems, especially when you have x to the first power and x to the first power in your binomials. You're going to see some terms that need to be combined. So 3x plus 10x is 13x plus 15. And oh my goodness gracious, we just took two binomials and we made them into a trinomial. All right, now I feel like you might be looking at what I did and saying, okay, looks a little bit like some, I don't want to say voodoo magic, but you know, looks a little interesting. Not sure I believe that those are really the same thing. Maybe you do, you trust me completely, but maybe you don't. So I'm going to prove it to you right now. I'm going to pick any number and I'm going to plug it in and I'm going to get the same answer for both of those problems. So no one can pick the number for me right now, so I'm going to pick -3. So I'm going to say, okay, let's say x equals -3. What do I get when I plug in -3 for x in both of these expressions? Okay, so that would give me -6 plus 3 times 2. Remember, you have to combine like terms inside of your parentheses before you can multiply. Do not use distributive property at that step. And then I get -3 times 2, which is -6. Okay, so this one equals -6. Let's look at the other one. 2 times -3 squared plus 13 times -3 plus 15. Okay. 2 times -3 squared is 9, so that'd be 2 times 9, or 18. 13 times -3, well, that's going to give me -39. And then I have positive 15 that just gets carried down there. What's 18 plus 15? I think it's 33. Yeah, 33. So then I have 33 minus 39, which also gives me -6. Wow! They are the same thing. You probably believed me, but I wanted to do that anyway. Okay, so distributive property, not that bad. It's a little bit of extra simplifying, that little step in the middle where you distribute and then you have to distribute again, basically, but not that bad. Let's do another one. Okay, so I'm gonna package up my x minus 2, make it ready for travel, and distribute. So I get, this time, I'm going to put the 3x out in front of the x minus 2. You're just multiplying them together. It doesn't make a difference. Hopefully that's clear. Yep, so that's what I've got here. That 3x plus 4, it's kind of divided up there, and then I've got x minus 2 being multiplied by both of those pieces, basically. Okay, so this middle step, I distribute again. Okay, that's what I get, 3x squared minus 6x plus 4x minus 8. Well, those are going to combine right there, and I get 3x squared minus 2x minus 8. Awesome. Okay, I want to do one more that's kind of like that. Really quickly, just to address something that might happen to you guys. I bet you're gonna have a problem like this somewhere. So if I take that y plus 8 and I distribute to the y and the minus 4, I get y times y plus 8 plus negative 4 times y plus 8. So do you see what happened there? If I have a subtraction sign here, that means that this is a negative 4. So you can think of this as the exact same thing as y plus negative 4. I don't know if that helps, but when you have a subtraction sign, you're going to essentially be treating it like a negative and addition and subtraction basically all at the same time. It means a lot of things. We can take it in a lot of different directions. So I'm going to erase my little question mark there because that's not helpful. Now I need to distribute again. I get y squared plus 8y. Now I'm going to do minus 4 times y, so 4y, minus 4 times 8, which is negative 32. And I get y squared plus 4y minus 32 as my answer. So the thing that I wanted to point out to you was that negative, or that subtraction sign, however you want to think about it, and the fact that it does exist and how you go about handling something like that. Okay, well, you've seen 3 of them now. It's a process. You can do it. You got the 1, 2, 3 steps. Let's give it a try, okay? Don't be worried. I'm sure you can get it. All right, I'll box this one up for you. Oh, look at that. It's all ready to ship to the M and to the 5. So give that one a try. Your answer is going to be 3m squared plus 19m plus 20. So hopefully that's what you got. Let's do one more try problem. Nah. Let's not. Let's just move on to the next thing. So this is one of our ways of multiplying binomials. This is going to come in handy because we're going to multiply polynomials the exact same way. However, I think I mentioned binomials are a little bit special. So what we've done here is going to be very important for part 2. There is something else that we can do with binomials specifically, and no other polynomials, that we're going to learn right now, and it's going to make the process faster. It's called FOIL. And it's an acronym like PEMDAS. Or if you were in the class that we did SADMEP, yeah, it's also like SADMEP, but more commonly used than SADMEP. And it stands for first, outer, inner, and last. That's what FOIL stands for. Now, what are they talking about? Well, here. If I have x plus 4, and let's say x minus 2, each of these binomials is, separate. It's unique. We've got a first term for both of these binomials, right? This is a first term, and this is a first term of the other one. So what they mean by first is, let's multiply the first ones together. Okay. Here, we'll put this first. So that's going to be x times x. Then we're going to do the outer. And of course, I put a plus because I need subtraction. The outer ones are going to be the ones that are on the ends. So that's going to be x and negative 2 for this particular example. So I'm going to x and negative 2. That's how I'm going to write it. We're halfway there. All right. I for inner, just like the last two that we were talking about were outer because they're on the ends. Inner, they are in the middle, okay? So we're going to look at the two that are in the middle. Inner, so 4 times x, plus, all right, the last one's just the opposite of the first, okay? These are going to be 4 and negative 2. And that's FOIL. You're multiplying the first terms, then the outer terms, then the inner terms, and then the last terms all together. And then we are going to do a step that's basically what we were just doing. So the simplifying, so that gets x squared minus 2x plus 4x minus 8. X squared plus 2x minus 8 is my simplified version. So really quickly over here, I'm going to do a little side note. So if you, I guess if you really don't want to watch my cool little thing that I'm going to show you over here, you can skip ahead a few seconds. We won't be looking for this in the notes as much. But I'm going to show you, doing it the way that we just did on the last page, how this still works to prove that these are the same method and kind of compare where each step is, because they have the same kind of steps. It's just where. So x plus 4 times x, and then plus x plus 4 times negative 2. Okay, now I do my distributive property, and I get x times x plus 4 times x plus negative 2 times x minus, well, this is negative 2 times 4. Does that look familiar? Interesting. And this is going to shock you, but the last two steps are going to be the exact same, okay? So I end up with x squared plus 2x minus 8. So the exact same thing. This is a little aside saying, okay, both of these are legal moves. Now, FOIL, the benefit of FOIL is that it takes out one of our steps, and we all like using our time wisely. So we are going to use FOIL so that we don't have to work quite as hard. We all love those shortcuts. Okay, that is what FOIL is. Let's look a little more at using it for example 2. Okay, so if we have the binomial 2y minus 7 and 3y plus 5, and we want to multiply them together, I am going to use FOIL to help me do that. So first, outer, inner, last. First, outer, inner, and last. Oops, I forgot to draw that one. Okay, so something to remember, this is important. You are only multiplying things together that are in separate parentheses. So if they are in the same parentheses, then you do not multiply them together. There is nothing where you're going to be multiplying like the 2y and negative 7. You have to be going with your arrow or with your line from one to the other, one to the other, one to the other, one to the other. So you have to make sure that you're not multiplying things that are in the same binomial by themselves, because that's not going to work. And I can just picture with first especially or last, potentially people saying, oh, well, these are the first two, so I'm going to multiply the first two together. It's going to be the first of each individual binomial. You should never be multiplying something like the 2y and the negative 7 or the 3y and the 5 together. But let's continue. We're going to get 6y squared when we simplify that plus 10y, that's minus 21y, and then minus 35. I simplify that again, and I get 6y squared minus 11y minus 35, and that is going to be my answer. So it's breaking it down into nice small steps, so we've just got to remember how to do the steps correctly, and our lives are going to be so much better. Here's the next one. First, outer, inner, last. And then I'll write it up here too. First, outer, inner, and last. So the first ones are going to be 4a times 2a. I'm just doing another example. Don't remember if I said that or not, although it's pretty obvious. All right, and then I have outer, which is going to be 4a and negative 9. Then the inner is going to be, well, negative 5 times 2a. And then last is going to be negative 5 times negative 9. So that's the last. Cool. We just simplify. Let's see what we get. 4a times 2a is going to give me 8a squared minus 36a minus 10a plus 45. Let's simplify by combining like terms. I'm going to get negative 46a. Not that. Negative 46a. And then add 45 to that. Okay. We are going to do tons of practice on this in class, but I want you to try one right now and see how it goes. So I'm going to help you out. I'm going to draw this for this first one. First, for the first one. Outer, inner, last. All right, have at it. See what you get. That's what you should have gotten. Let's do another one. All right, I'm not going to draw the lines for you. You're going to have to foil it yourself. Go ahead. You should get 12b squared minus 7b minus 10. Okay, well, I am actually going to leave it right there, but I want to point out one more thing. This is a linear expression because it's degree 1. This is a linear expression because it's degree 1. The polynomial is degree 1. And then what we are getting consistently when we multiply a linear and a linear, so you can look back at the notes, that's all we've been doing this whole time, is multiplying something that's degree 1 by something that's degree 1. When we do that, we are getting a quadratic, we call it, or degree 2. We're getting a degree 2 every single time. We have talked a lot about things that we call linear functions. That's going to mean the exact same thing. If you were to graph these things, they would look like a line. That's why it's linear. Quadratic is what this chapter is about. So that's the next type of function that we're going to be looking at. All right, I'm going to give you a big smile. Just want to say thank you to everybody for being so awesome, and I hope that you are doing well, not stressing out too much. If you are having any issues, please let me know if I can help, or just let me know, and then maybe I can figure out a way that I can help you out with it. This is these are, as you know, unprecedented times. My favorite phrase ever. But they didn't say it at the last staff meeting, so we were all winners that day. All right, enough about those unprecedented times. See you tomorrow.